Hello and welcome to Math 154, Unit number 2, Homework number 1, Practice. So at this point, you should have already viewed the video or had in-class experience with the notes, which ended just above at the top of my page here. So this video is going to act as a guide to the practice problems, a review for the practice problems, or a way for you to check your answers to practice with some explanation. Let's go ahead and get started. Suppose a 4-year-old boy is currently 39 inches tall and you are told to expect him to grow 2.5 inches per year. Does this scenario describe linear or exponential growth? Okay, so you should select linear. Okay, now let's talk about why this is linear. This is linear because he's growing 2.5 inches per year. So this is repeat addition, okay? And we're adding 2.5 inches per year. Determine what age corresponds to n equals 0 and use that information to determine p sub 0, the boy's height when n equals 4 for the problem. Okay, so in our problem it says we have a 4-year-old boy. So at age 4, we're at n equals 0. And it tells us that the boy is currently 39 inches tall. So that means our p sub 0, also known as our initial value, is 39 inches. Write an explicit formula that models the situation described. So p sub n is equal to our initial value, 39 inches, plus the rate of change, or the growth rate, 2.5 inches, where n is representing the number of years, okay? And that's number of years since age 4. Now, another way you could write this, maybe you're more familiar with, 2.5n plus 39, either way. Use your answer to part A to determine what values of n correspond to the following ages. Age 6, what is my n value? Okay, well, let's think about this. N equals 0 is 4. That means n equals 1 is 5. That means n equals 2 is 6. Now we got to have a faster way to do that here because, you know, n equals 3 would be 7, n equals 4 would be 8. So the key here is to take the age, 10, and subtract off age 4 because we started with 4, and that would give me an n value for 6 here. So I can repeat that process down below. So I have 20 minus 4, so that'll get us 16, and then 50 minus 4, and that'll get us 46. So that is the n value that I would substitute into the equation, which is what we're going to do here in letter E. Use your answer to part D to evaluate the appropriate p sub n to determine the boy's predicted height at ages 6, 10, 20, and 50. Okay, so predicted height here at a 6, that's when n equals, we said that was when n was equal to 2. So we're finding p sub 2. So that's 39 plus 2.5 times 2. So you calculate that on your calculator, you should come out with 44. All right, so you go ahead now and use the appropriate n value from D and calculate the values here for 10, 20, and 50, and then we'll come back in a moment and check your answers. So go ahead and put pause on the video, and we'll be back in a moment. Okay, so welcome back, and so let's check your answers. So for 10-year-old boy, what was your height? Great, 54. Okay, for 20-year-old boy, well, now he's a man. How tall was the man? Okay, 79. And then at 50, based on this model here, we should have come up with 154. All right, so part F, discuss your findings with your group. What conclusions can you make? All right, so if you've already worked with your group, maybe you have some answers here. If you haven't worked with your group and you're working alone, go ahead and take a moment and think about what might you conclude about this scenario here. Okay, so what did you come up with? What kind of thoughts here? So maybe you came up with, and you might not have it in these exact words, but maybe you said the data is reasonable for 6, 10, and 20 years. Okay, because let's be honest with each other, 50-year-old person being 154 inches probably isn't going to happen. So think about yourself as you're growing. Were you still growing at age, or would you still be growing at age 30, 40? Or if you are over those ages, did you still grow at ages 30 and 40? So, you know, you probably stopped growing. Okay, you probably stopped growing somewhere around, you know, I don't know, in terms of this model, around 20 years. So if you want to check it out, go ahead and Google, if you got an extra minute, or ask Siri here, what is the tallest man recorded? And you'll probably find that it's not going to be 154 inches. All right. If you did this in class, you maybe came up with some class conclusions. If you're doing it right now by yourself, let's come up with some conclusions together. So our conclusion here, we've kind of alluded to it here based on the last problem. So we need to, let's say we need, to be careful, okay, when we, all right, now I'm going to use a new vocabulary word here for you. All right, so the word here, this means to, this word here means to make predictions about the future using a model. So when we're making predictions about, you know, the future, or when we're looking at our model here, we need to be really careful. So when we need to be careful when we extrapolate data from a model. All right, now why is that? Okay, so in our case, as we talked about, are you really still growing at age 40? So in our case, let's just say consider the real world limitations. Okay, so we need to consider real world limitations for our model. And that those limitations are different, obviously, for every type of model. Okay, let's go ahead and look at problem number 2 here. Identify the information given to you in the application problem below. Use that information to answer the questions that follow. Round your answers to 2 decimal places as needed. The equation P equals 490N minus 10,290 represents a computer manufacturer's profit P when N computers are sold. Identify the slope. Complete the following sentence to explain the meaning of the slope. Okay, so what is our slope? I think most of you can agree. The slope here is 490 based on the way the model is. All right, so let's remember here. The slope is the rate of change. Okay, so our slope here is rate of change. So what are our units here? So our units, remember, slope is rise, also known as the y units, which are output, over the run, which is known as the x values, or the input. Well, let's think about what our output here is. Our output here is the P. What is P? P is our profit. So we're outputting a profit. This little line, we can think of this meaning per. In our input here, what are we putting in? We're putting in N. Our N is computers. Okay, so we're making you know, dollars per number of computers. So our slope here, this tells us that we have $490 per computer. So we're making, the company here earns a profit of $490 per computer sold. So this think of as my output, there's my per, and then computers was my input. So computers sold. All right, find the y-intercept, write your answer as an ordered pair. So I think most of us can identify the b value here is negative 10,290. So there's our y-intercept. Now let's complete the sentence here and evaluate it. So if the company sells, now remember x was our our number of computers. So we're selling 0 computers, they will not make a profit. And that's because we have a negative here. How much are we going to lose? Well, we're going to lose $10,290. So it's telling us here that in order to run our little computer company, it's costing us $10,290, and we haven't even made a computer yet. Find the x-intercept and write your answer as an ordered pair. So when you're finding your x-intercept, that means you want to let y be 0. Okay, so if we let y be 0, in our case, p is where the y would be. We would have 0 is equal to 490n minus 10,290. So if we solve this equation, we have 10,290 equals 490n. Divide each side by 490, and so we get n equals 21. That's telling us that we have 21 computers. So think about this on a graph. Okay, here is my x-intercept on the x-axis. Notice that corresponds to a y value here of 0. All right, so if the company sells 21 computers, that means we have a profit of $0. In terms of $0 here, that means we're going to break even. Okay, so we're going to break even and earn $0. All right, now let's evaluate P when n is 36. All right, so this is telling us that we are selling 36 computers and we want to figure out what our profit is. So we're going to substitute 36 into our equation for n. So our profit is equal to 490 times 36 minus 10,290. Punch that up on your calculator. All right, and we get a profit to be $7,350. So as an ordered pair, I'm 36, 7,350. So what does that mean? Well, it means that when we sell 36 computers, that we've earned $7,350 in profit. Okay, now there's another way we can look at this. We can say, all right, I want to make a certain amount of profit. How much do I need to sell? So that's in this part here, finding the value of n when profit is equal to 17,640. So this is a p-value, so 17,640 is equal to 490n minus 10,290. Solving this equation for n here, so we have, let's see, 27,930 when we add 10,290 to each side, divide each side by 490, and we have n equals 57. All right, so this is telling me that I'm going to earn a profit of $17,640 when I sell 57 computers. Now, as an ordered pair, you know, that's going to look like this: 57 computers and $17,640 in profit. Okay. Okay, let's look at another linear example here for modeling. So here I have a population of beetles are growing according to a linear model. The initial population, and I'm telling you we're starting at week 0, is P sub 0 is 3. What is the population, and the population after 6 weeks is P sub 6 equals 57. All right, so what we have here is our initial model. P sub n equals P sub 0 plus dn. All right, so d is some value, our rate of change essentially here. All right, so we were given the initial amount. So the initial amount creates the ordered pair 0, 3. Okay, so week 0, 3 beetles. We also were told that at week 6, we had 57 beetles. So what we end up with here is two ordered pairs, and we need a linear equation. So to get our linear equation, the first thing I need is a slope. So that's the difference in the y's over the difference in the x's. So you might have seen this as y, or x1 and y1 here, x2, y2. And then slope formula, you should know from your notes, y2 minus y1 over x2 minus x1. Okay, so we end up here with a 54 over 6, which tells us that we have 9. So in terms of our problem here, this is telling us that every week we're going to increase by 9 beetles. Okay, because what is our input value? Our input value, our x, which is the denominator, is weeks. Our output value, which is y in the numerator, is beetles. So we have beetles over time here, so 9 beetles per week. Okay, so I have an equation here, or I have part of my equation. Now I need to find the b value. So to find b, or the initial value, I'm going to start again with y equals mx plus b, or I can say p sub 0 plus dn. It's the same exact scenario here. Okay, and solve for b. Choose one of the ordered pairs. I would choose the first one because that has easier numbers. So 3 in for y, 9 in for the slope, 0 in for x plus b. B here is equal to 3. Now, I really didn't need to do this step because it also gave me the initial value. Giving me the initial value, that is the p sub 0 here, which is also known as the b value. So p sub n is equal to my initial value, my b value, or my p sub 0, which is 3, plus my m, or my rate of change, 9, times n. Now, x is, kind of what we generally think about when we're in the y equals mx plus b form, but this just means the same thing. So part B, after how many weeks will the beetle population reach 246? Okay, so this is a population, which is, an input. This is weeks, which is n, which is what we don't know. So we have a population P of 246 is equal to 3 plus 9n. We want to solve for the number of weeks here. So go ahead and solve that equation and come back in a moment and check your answer. Okay, so what did you get? So we should have, let's see here, 9n is equal to 243. Divide out 9 from each side, and we get n equal to 27. So we have, after 27 weeks, we're saying that we have 246 beetles. All right, let's look at another example here, maybe fairly applicable if you're going on a trip. Consider the following scenario. Person is 450 miles from home and drives towards home at an average rate of 42 miles per hour. Part A, write a linear equation in slope-intercept form that models the distance the driver is from home. Okay, so let's think about this for a moment. If you are 450 miles away from home now, as you go towards your home, the distance is decreasing, okay? Because we're already 450 away, so distance from home is decreasing, all right? So in terms of our initial starting point, this is my starting value, 450. In terms of my rate of change, this is my rate of change right here, okay? So I want to write a model for this situation here. So I have y equals my rate of change, 42x, and then my starting point, my b value, plus 450. Now, let's think about this slope for a minute. I just emphasized that your distance is decreasing. If my slope here is decreasing, I need to have that be a negative value. So I need negative 42 here. Okay, what does the variable x represent here? Okay, so if we're driving at 42 miles per hour, okay, the x variable here is going to be our hours driven. And the y variable, the output here, is going to be our distance from home. So if you're on a trip and you want to figure out how far you are away from home after 7 hours of driving, now you can compute that based on our model here. If your average speed is 42 miles an hour. So you have negative 42 times 7 plus 450. We come out with 156. So after 7 hours of driving, you're still 156 miles away from home. Okay, so this concludes your practice problems for homework number 1 of unit number 2. Thanks for watching.